Okay. So, hello, hi, namaskar, and a very good evening to all those who are connected here with me. And उन सभी को मेरा प्रणाम जो मेरे videos YouTube पे देखते हैं. I am Prashil Badwaik. I am a chemical engineering graduate from VNIT Nagpur and currently working with Godrej Industries. So हम सब मिलके यहाँ पे गेट की शानदार प्रिपरेशन कर रहे हैं और मैं इन सभी लोगों को केमिकल रिएक्शन इंजीनियरिंग पढ़ा रहा हूँ. So let us begin the session of the day. I'll quickly recap what we studied in yesterday's class. So हमने क्या किया था? We started with our temperature effects, right? In the temperature effects, we have seen different graphs for exothermic reaction and endothermic reaction. What happens actually, like temperature increase hota hai ya decrease hota hai. Then we found out standard graph, right? Standard graph between your temperature versus your conversion, right? Conversion. This was your standard graphs. Okay. Then we were on the way to calculate what is your equation for operating line equation I'm saying. So it is in the form of initial temperature is equals to, or I'll say final temperature is equal to initial temperature plus some mx, right? So this is your operating line equation. So ये equation we found out for CSTR, right? CSTR, ideal CSTR के लिए find out किया था. Now in this class we'll calculate this operating line equation for what? We'll proceed towards your plug flow reactor. Okay, plug flow reactor. So you write down energy balance over plug flow reactor, energy balance over PFR, energy balance over PFR. Okay, so can you please tell me what is your equation for temperature change or maximum temperature change in adiabatic condition for CSTR, which we studied in yesterday's class? What was that equation? I told you how to remember also.
Minus F node into delta H reaction by summation of F node CP bar.
Okay, delta H reaction, F naught into XA is also there, right?
Sir,
So I
for
told
maximum temperature rise, XA is equals to 1 now.
X equals to 1. Okay, okay. But generalized, you can write XA. So you will be having Ti minus Ti naught, right, is equals to your what is converted, right? That is your Fa naught into XA into your minus delta HR reaction. I am writing here minus, okay, minus delta HR reaction divided by at which rate, or I'll say what is your total energy in. Total energy is your Fi naught into your CPI mean, right? So this is what top, or I'll say this numerator is saying you, that is your what is converted. Wait a minute. What is converted with delta H divided by, I'll say what is your total inlet of energy. You can have this equation easily, and you must have seen, or if you have solved, you would have found key most of the questions were from this topic only. So you need to find out temperature change. Okay, abhi when I am writing design equation of MFR, what is that? Design equation of MFR, that is your, see it is for MFR. MFR में क्या था design equation? It was your V divided by Fa naught is equals to tau divided by Ca naught is equals to your Xc divided by minus Ra at exit of reactor, right? While in case of your PFR, what was that equation? V PFR divided by Fa naught is equals to your tau divided by Ca naught is equals to your integration dxa divided by minus Ra, right? Why it is your minus R in integration and it is your exit of reactor? You all know this, right? What is that reason? Here in TFR and MFR, anyone would like to share? Why there is integration and here it is not integration? Because the composition
Concentration changes continuously.
what? Because the
In
composition.
PFR, the concentration use.
Yes, it is. It is eventually it is changing in case of PFR, right? So it is your
Yes.
profile like this. It is concentration changing over your length of reactor. Okay. So here I am saying it is a continuous function, right? And a main reason is what? Your minus RA is a function at every time it is function of concentration here, and here concentration is dropping your eventually. So यहाँ पे you will follow your core, right? You will follow the curve and you need to find out what is area under the core. Okay, then here यहाँ पे क्या होता था? In case of your MFR, you are having initial concentration Ca naught. Inside of reactor, you are having Ca, and out of reactor, it is your outlet is your Ca. So here you can see inlet and outlet concentration is same. So we are finding out what is your minus Ra at exit, right? Here, as soon as the Ca naught it fall into your reactor, it get convert into Ca. It is no more Ca naught. Okay, suppose Ca naught is your 300 moles per meter cube. If it is, take an example. So Ca will be your around 30 mole per meter cube. Sudden drop in the concentration will be there, and here we are considering exit. So Abhi, can you please guess what should be your equation in case of temperature change when I am considering temperature change? Here in case of PFR क्या होता होगा? You can see what has been changed here. क्या change हुआ है? यहाँ पे इंटीग्रेशन नहीं था, यहाँ पे यू आर हैविंग इंटीग्रेशन. तो इधर क्या होगा? सिमिलर, यहाँ पे भी एक इंटीग्रेशन का टर्म आएगा. So in case of PFR, when you are balancing for temperature change, so you will get an equation of the type. कैसा type रहेगा? I am just guessing. Okay, it is not exact equation. So we'll be having Ti minus Ti naught. This is your initial temperature Ti naught is equals to your integration same. What is your Fa naught? Your dxa will be there, and here delta Hr reaction minus में, and this is your minus sign. क्या रहेगा? डिनोमिनेटर में सेम, राइट? Fi into your Cpi mean. Similar kind of equation you are getting. यहाँ से you can find out delta Hr reaction तो common निकल जाएगा because it is not changing with respect to your conversion. It is for overall reaction. Your Fa naught is your constant, then integration आएगा dxa divided by what? Integration. It is your Fi into Cpi mean. One thing is missing, that is your summation sign, right? So summation sign will be here. C. So there is a similarity between these two equations. So when we'll derive, you will get such kind of equations. But I'll ask you one question at the end. You can differentiate what is your difference between these two equations. Okay. So we'll quickly move on to how to find out. Okay. Equation for PFR. But you can have an idea कि इस type में आएगा कुछ, right? So PFR में we are assuming concentration क्या रहता है? Changing continuously. So we are finding out a small strip जहाँ पे your concentration change is very negligible. Okay, and that is your DCA. Concentration change is your DCA. So this is your PFR. This is your PFR. This is your inlet, and this is your outlet. Okay, this is PF. Now your Fi naught is your inlet. This is Ti naught is your inlet. Fi and Ti is your outlet, as we did in CSTR. We are having reaction. A gives product. A gives product. And what is your Vp divided by Fa naught? That is your integration dxa divided by minus Ra in case of temperature as constant. Okay, design equation was this. Now in this case, what we will consider, we'll take a small strip because you know concentration is changing. So we'll take one differential volume. You can write differential volume, जिसका volume is dV, right? Here it is V, here it is V plus delta V. Okay, and we'll balance around it and then we'll integrate. This is the basic idea. Now energy balance के लिए what was your unit? It is your kilojoule per second. कैसे adjust करेंगे? You can have Cp of mixture, then rho. Okay, rho Cp T, right? Rho Cp T. This is one kind of balance, and second is your directly from your moles. So you can write joule per second is equals to here mole per second and into your kilojoule per mole. So you can have answer that is kilojoule per second. So what is your mole per second here then? Mole per second, molar flow rate, that is your FA.
FA naught.
What is, yes, FA or FA naught, and then you will be having kilojoule per mole. What is kilojoule per mole? That is your enthalpy, right? Molar enthalpy. So this is your HE, I'll write. So similar kind of balance you need to do here. Input energy in minus your energy out, plus minus of heat exchange with surrounding minus of your shaft work done on the system is equals to 0. I hope you are aware of this steady state condition. In yesterday's class we did the same. Abhi, what is your inlet? In क्या हो रहा है? I, right? So I could be any A, B, C, what and all number of component will be there. All will be coming under I. So I'll sum it over I. So summation Fi into Hi, it is entering at V minus summation of Fi into Hi at V plus delta V, right? Plus minus of Q minus Ws is equals to 0. This is your equation. Suppose if I am assuming there is no shaft work or shaft work done on the system is negligible, so you will be having this equation. क्या होगा? What is my next step? I need to convert this into your differential term. कैसे करेंगे? Maybe you know what is your df by dx, that is your f dash x. क्या करते थे हम? Limit delta x tending to 0, right? F of x plus delta x minus f of x divided by delta x, right? This was your definition of limit. So according to this definition, यहाँ पे क्या करेंगे? यहाँ पे वॉल्यूम में डेरिवेशन दिया और I'll say volume we are considering differential volume. So we will be having limit delta v tending to 0, right? तो इसके लिए पहले तो हमें डिवाइड करना पड़ेगा डेल्टा v से. So please divide everything by delta v. So we'll be having this equation just divided by your delta v divided by your delta v, and here it is delta v, right? And we apply limit here, delta v tending to 0. So what will be your equation then? Anyone? That is असल में डेल्टा v tending to 0 करना है. You can see here, you can use this equation. This term is given, this final term is given, right? Limit and everything is given. That will be your f dash x, that is your df by dx. So यहाँ पे क्या होगा? d by d v of
Fi, Fh.
yeah, right? Fi into hi, and that is your minus sign, right? Because it is final minus initial, it is written, and it is your initial minus final is written. So that will be minus sign. So you will be having minus of d by dv of summation fi into hi, right? Plus minus of your q rate divided by dv. So I'll write here dq is equals to your 0. Okay, यहाँ तक आ गए थे, right? So this is your equation. I hope you are getting this. Okay. So this is your all about your heat generated, I'll say, in reaction or something that is coming or input output heat. input output generation and all will be there, and this is your removal, or it is if there is need of addition. So this is excess heat, external heat, I'll say external heat term. Okay, external heat term है. If I am defining qa is equals to your heat exchange area per unit volume. तो हीट एक्सचेंज एरिया क्या है तुम्हारे, दिस इज योर डिफरेंशियल वॉल्यूम राइट, जो हमने कंसीडर किया था, दिस इज योर v, इट इज योर v प्लस डेल्टा v. So what is your heat exchange area here? This area, right? This surface area and volume, you know, volume of cylinder. So you'll be having, what is your heat exchange area? This is your circumference into this length, right? So this is your surface area available. So what is that?
2 pi r dv.
2 pi
Right?
r delta L.
Okay, 2 pi r into your L or delta L, you can say. Okay, so I'll write here pi dl or delta L. Okay, and what is your volume then? Volume of cylinder. So it is your pi d square by 4 and into your length. So what is that? This is your 4 by d, 4 by your diameter. So this is your diameter here, diameter of this your PFR, this value. Okay, or I can write A is equals to your dA divided by dV. So please replace, what can you replace here? Okay, before that we'll find area into dV is your dA, that is your heat exchange area, and heat exchanger, this is your equation for heat exchange area. यहाँ तक आ गए थे. And तुम्हें मैंने previous class में बता दिया था, suppose if there is generation of heat or there is a removal of heat, you are using what? Heat exchanger design का principle, that is your amount of heat that is added or that is removed is equals to overall heat transfer coefficient area, that is contact area, into your Tc minus Ti, right? Tc is coolant. If there is need of heating, then it is Th, right? So based on which your sign will be there. So your overall heat transfer coefficient U naught, this is your contact area, and this is your coolant or heating का जो media है उसका temperature, and this is your inlet temperature, inlet or inside reactor temperature. यहाँ तक आ गए थे. Now please replace this contact area using this equation, equation 1. So you will be having dq is equals to u naught, then you will be having area, right? Then dv, area per unit volume into volume, and it is Tc minus T. So this is your equation. Please substitute this equation 2 in your equation 1. You can say this is your 2, this is your 2, and this is your equation 3. Please substitute 3 in 1. So what you will get? You will be having equation summation, differential summation Fi into Hi divided by your dV. This is with minus sign, plus minus your UA dV Tc minus T divided by your dV is equals to your 0. So we will be having this term cancel out. So we will get d by dV of summation Fi into Hi plus minus UA Tc minus T is equals to 0. Final equation. Final equation. And here A is your area per unit volume. Unit volume में what is surface area that you are getting? It is your A. By the way, this is just I'll say these are just steps how we are approaching. Don't need to mug up the steps. Okay. Exactly. So this is your equation, generalized equation, equation A. Now case 1 you write adiabatic condition. Generally adiabatic condition is given. Adiabatic condition क्या होगा? Adiabatic condition में dq is 0, so ये whole term cancel, right? You are not exchanging any heat with surrounding, or there is no addition of heat from surrounding. So dq is equals to 0. Then you will get equation. This term will remain only. Please differentiate using your principle. First function derivative of second, and second function derivative of first. So this is your minus of summation fi into d hi divided by dv minus summation of hi into d fi divided by dv. Even I have given you hint what kind of equation you are getting at the end, just at the starting. Okay. What is your dhi from previous class? dhi is your cp mean into your dt, right? divided by dv करोगे तो dt divided by dv आ जाएगा. Equation 4. Then for a reaction AA plus BB gives CC plus DD, suppose if it is. So for PFR, what equation you are getting? Before integration, that is your FA naught dXA is equals to your minus RA into DV, right? कितना convert हुआ? कितना convert हुआ is equals to your rate into DV, right? Okay. So from this you can have your equation, that is your DFA. DFA is your FA naught into DXA. DFA divided by DV, right, is equals to your minus RA into minus RA is only. Anything missing here? It is reactant, so we will be having minus sign. Minus DFA is equal to FA naught into XA. Okay, this is for A. For B, it is your minus D of B divided by dV into your minus RA divided by A multiplied by B, right? Divided by A multiplied by B, and that is also equals to your minus RB. Just I replace in terms of A. So what will be your generalized equation then? Rate per unit your limiting component or limiting reactant into your stoichiometric coefficient of particular component. See, यहाँ पे हमें जब B का रेट निकालना था, so we found out per mole of A and then we multiplied by stoichiometric coefficient. Generalized equation will be your dFi divided by dV. I am considering ith component Vi into your minus Ra in terms of A. This is your generalized equation for any component in terms of minus Ra. Please remember, in terms of minus Ra. This is your equation. Please substitute equation 4 and 5 here. You will be having Fi Cpi dt by dv with minus
Sir,
sign.
here
Okay.
Vi into minus RA by A will be there, no, sir, like limiting reagent code.
Okay. Yeah, it is there. So here you can say this minus Ra dash you can consider, and this minus Ra dash generally I am considering as per unit your A. That is your per unit A.
Yes.
Per mole A. That is your dash. You can write that. Okay.
Yes, sir.
So in terms of minus Ra, or you can also consider कैसे Suppose if you are taking minus RA, as it is minus RA लिखा है, so what is this? This is your B by A is there, so you can have how much moles of B reacting per mole of A, right? So just stoichiometric ratio, stoichiometric coefficient का ratio it is. So you can have that concept also, like what and all B I am using per mole of A. That much. Suppose it is A, or I'll say A reacting with twice B, right? So for 1 mole it is 2. So you can write 2A is equals to 4B. So इसमें भी क्या होगा? You will get same. Per mole of A कितना लग रहा है? It is same. 4 by 2. It is 2 by 1. Both are same. So we can say it is stoichiometric ratio, and you can replace this as minus RA only, and you consider this nu as stoichiometric coefficient, or previous concept I told you, दोनों चीजें are valid. Okay, so this is your stoichiometric coefficient का ratio or per mole of your A. Then you replace, ये हो गया. What was your final equation then? This is your minus summation Fi Cpi mean dt by dv minus summation of hi nu I, and it is minus Ra is equals to 0. So please replace this term. What is that? Summation of hi into nu I, and this is per mole of A. This is your enthalpy change or your heat of reaction. I write delta HR reaction per mole of A. Enthalpy of reaction per mole of A, right? So we'll be having this equation minus summation of Fi Cpi mean dt by dv. Ultimately you are getting the equation which we derived in CSTR. It is similar, just integration will be there and a little change. So ये आएगा तुम्हारा delta HR reaction at temperature T into your minus Ra is equals to 0. I am replacing everything in terms of minus Ra, and your minus Ra is what? What is converted? dxa divided by your dv. So you can have this value also. Fi naught dxa by dt, dxa by dv. So you can have this concept ki whenever I'm writing enthalpy, this is per mole per here, per mole I have derived, and दूसरी चीज is you are taking minus Ra directly then, and you can replace this minus Ra by Fa naught dxa by dv. This is from what? Your design equation. So you will get equation like, if you replace this, dt is equals to dv तो cancel कर दो, minus summation of Fi Cpi mean dt by dv minus, so write plus plus both cases, that is by the way or 0 on other side, delta HR reaction at temperature T Fa naught dxa divided by dv. Please remove dv and take out what is value of dt. So you will find similar equation. dt is equals to your Fa naught, delta HR reaction at temperature T dxa divided by what is your total input. यहाँ पे बस change हुआ है, क्या change हुआ है? Just tell me. And dt is your minus, right? Ti minus Ti naught था ना, final minus initial, that is where this. So you will get dt is equals to Fa naught minus delta HR reaction, Fa naught minus delta HR reaction at temperature T into your dxa divided by summation of Fi Cpi mean. Please tell me what is your difference there. This is your final equation. इसे हम इंटीग्रेट करेंगे फ्रॉम टेम्परेचर Ti to Ti naught, right? Limits क्या रहेंगे Ti to Ti naught, and what is your XA? That is your 0 to XA. Sorry, please change here. It is your Ti naught to Ti, right? Initial to final temperature रहेगा. That is your Ti naught to Ti and 0 to XA. Please put the limit and calculate what is your equation. Ti minus Ti naught final minus initial is equals to your Fa naught. Integration you write first. Fa naught delta HR reaction at temperature T dxa divided by your summation of Fi Cpi mean with minus sign, right? So that is Ti minus Ti naught is equals minus Fa naught or Fa naught delta HR reaction at temperature T integration dxa by summation of Fi Cpi mean. And I'm writing here just a small change. Nothing has been changed, just I'm replacing minus delta HR reaction at temperature T. This is your final equation. Please star it. In case of adiabatic condition, adiabatic process, can you please compare it with your CSTR equation and please tell me the changes. क्या change हुआ है? Change is what has been changed?
Sir, like we got integration here.
Okay, integration. Second, what was there? Fi or Fi not?
Fi.
In CSTR,
CST or Fi not.
Fi node. Fi
right?
node.
यहाँ पे क्या हुआ है?
Yes.
चेंज हुआ है,
Fi.
राइट? Fi not is replaced by your Fi only. बाकी पूरा इक्वेशन सेम है, right?
Yes, sir.
पूरा इक्वेशन सेम है. You are getting exactly similar equation, so you know you don't need to remember for PFR and batch reactor. एक तुम्हें इक्वेशन पता है, उसी पे क्वेश्चन आने वाला है, and you know the concept how to derive the steps. Okay, एक्चुअल में स्टेप्स नहीं किए तब भी चलेगा, but you should know how I calculated that equation, so you will get a feel कि हाँ this was a step and ऐसे ऐसे हमने calculate किया था, और this is the procedure for calculating. and equation तो तुम्हें आ गया है, it is similar, right? what is your ratio? Same जैसे कैसा था, it was a ratio. what is converted by what is your total input? so input की जगह यहाँ पे it is what is converted. Here it is not Fi not, right? It is Fi. And Fi, what Fi is your function of conversion, right? Fa क्या होता है? Fa is equals to Fa naught 1 minus of Xa. so CSTR में क्या होता था? It was Fa naught. अभी तुम्हारा Fa है, so you need to find out in terms of Xa, right? That is your change. Here Fi is your function of conversion. That's why it is under integration. You please write Fi is function of conversion. And in special case, you write special case. If it is not function of conversion, right? Summation of Fi into Cpi mean is not function of your XA, then क्या होगा? Your equation will be
Same as CSTR.
except this Fi, right? Ti minus Ti naught is equals to Fa naught minus delta HR reaction at temperature T XA divided by your summation of Fi into CPI mean, right? It is similar. I am saying similar, not exact. It is similar to CSTR. Okay. Now please tell me. This is your final equation. Okay, don't need to confuse. This is your final equation. Triple star. What is your maximum adiabatic temperature rise? Tuja, I think you are familiar with this. That is your delta T. Final minus initial. What is that?
At x is equals to 1.
So कैसे करेंगे? Maximum
0 to 1 limits put करके.
right? Okay, that is correct. Good. Maximum temperature rise in adiabatic case क्या हो जाएगा? That is your Fa naught minus delta HR reaction at temperature T. Please remember it is not at standard state. It is at temperature T. Generally student confused हो जाते हैं कभी. 0 to 1 dxa divided by your summation of Fi CPI. Final equation for maximum adiabatic temperature rise in case of PFR. Okay, so we'll do balance over batch reactor now, and then we'll solve some questions. Okay, previous year's questions, gate questions. Generally 2 mark का question आ ही जाता है एक साल में. Only 3 formulas, right? 3 में से you need to remember only 1. Everything is similar then. Should I move? Should I start?
Yes, sir.
Yes, sir.
Yes, sir.
ठीक है. So energy balance over batch reactor. Generally questions asked on CSTR because there is no integration term and that question will not be lengthy one, so that you will be having easiness while solving. This is your batch reactor, stirrer or agitator. I will show you how batch reactor actually looks. I am currently handling batch reactor in industry, so we'll be having feel कैसे दिखता है actually में कैसा रहता है. This is your batch reactor. Whenever I'm saying batch reactor, what is first thing that strikes in your mind?
Unsteady state.
Okay. Then
Accumulation.
accumulation. Next, seasonal production, limited production, and it is used for reaction with high residence time. If you want limited production and with high residence time रहेगा, तो you can go for batch reactor. So as he said, it is unsteady state operation. Concentration is changes with respect to time but not with respect to position. Okay. Seasonal production था. Limited production, I could say. Limited production and high residence time can be carried out. High residence time. ओके, यहाँ तक आ गए थे हम. बैलेंस कैसे होगा? water energy is generated, that is we are removing that energy. Okay, just step. That is your plus minus of Q. This is your heat added or removed. Shaft work, as we wrote in previous balance. What is then plus of what is minus delta HR reaction minus RA into your V. कुछ नहीं किया मैंने, माइनस आर ये साइन अंदर ले लिया बस. इज इक्वल्स टू अकोमुलेशन टर्म पहले नहीं थी, राइट? यहाँ पे अकोमुलेशन आएगा बिकॉज इट इज बैच रिएक्टर अनस्टेडी स्टेट ऑपरेशन. अकोमुलेशन जैसे तुम्हारा बैलेंस में क्या था, इनिशियली इट वाज माइनस आर ए इंटू वी, बट व्हेन वी अप्रोच टेम्परेचर चेंज, राइट? तो क्या हुआ था, माइनस आर ए इंटू वी जो था उसे जस्ट डेल्टा एच आर रिएक्शन से मल्टीप्लाई कर दिया. ओके तो नॉर्मल केस में क्या था एकोमुलेशन टर्म में, डी बाई डी टी ऑफ व्हाट, चेंज इन नंबर ऑफ मोल्स, राइट? एन था. अभी क्या होगा, इट इज योर डी बाई डी टी ऑफ योर एन ए सी पी इंटू टी. इसका यूनिट क्या रहेगा, इट इज योर किलो जूल रहेगा. सीपी का यूनिट इज योर किलो जूल पर मोल Kelvin. So if you multiply by temperature and if you multiply by moles Na, so you'll be getting kilojoule per only kilojoule, right? Only kilojoule that I wrote earlier. ठीक है, यहाँ तक आ गए थे. So you will be having final time as d by dt of what and all components are present inside, right? So it is summation Ni Cpi into T. I hope you are clear with this. The inlet outlet is 0, right? It is 0 plus something. Are you guys clear with this balance?
Yes, sir.
Okay. So Q का तो मैंने पहले बता दिया, it is your U naught A naught into your delta T. That is your TC minus T in case of coolant. It may be your TH minus T. Okay, don't confuse. Based on your sign of this will be there, right? क्या रहेगा coolant में, it is minus Q, right? And your heating media में it is plus Q. That means you need to supply heat in second case. Supply heat and need to remove it, right? यहाँ पे भी coolant दिया है, that means you need to, you are removing. That's why coolant supply, then it is heating. Similar kind of equations will be there. Okay, so I told you I'm not considering sharp work here. Okay, and case 1 क्या लेंगे हम, adiabatic. Case 1, else your equation is this, equation 1. तो case 1 में adiabatic condition और adiabatic operation. So Q0, ये तो ऐसे इजीली आ गया इक्वेशन. ये फर्म में कितना बड़ा था वो डेरिवेशन, Q0 कर दो फट से. So the equation is minus delta HR reaction at temperature T into your minus RA into V is equals to your d by dt of summation of Ni Cpi mean and T. Okay, Kaushik, can you please tell what is this Cp here? Is it molar or mass?
Molar.
Right? Molar means specific heat per mole, right? Specific heat capacity. Okay. नेक्स्ट स्टेप क्या रहेगी, तुम्हें चाहिए इन टर्म्स ऑफ कन्वर्शन. कैन यू गाइस रिप्लेस दिस माइनस आर इनटू वी, दैट इज योर डीएनए बाय डीटी minus में because moles are consuming, and it is equals to Na naught XA dXA divided by dt. Please replace. So your equation will be in terms of dt, it is Na naught minus delta HR reaction at temperature T dXA divided by what? Summation of Ni Cpi, right? Can you guys compare this with PFR? क्या चेंज हुआ है?
The flow rate change to moles.
राइट, फ्लो रेट क्या था उधर? मोल पर सेकंड था, यहाँ पे इट इज जस्ट मोल्स. तो हियर FA चेंज क्या है विथ रिस्पेक्ट टू PFR? चेंज विथ रिस्पेक्ट टू PFR is your FA naught is replaced with your Na naught, or FA is replaced by Na. Flow rate is replaced with your moles. Just that change for adiabatic condition. Now please integrate. Temperature initially Ti naught, then it is Ti dt is equals to what? Na naught minus delta HR reaction integration 0 to XA dXA divided by summation of Ni Cpi. इजी है ना या डिफिकल्ट लग रहा है? सब इक्वेशन सेम आ रहे हैं, जस्ट अप्रोच इज डिफरेंट, बट एट द एंड यू आर गेटिंग सेम रिजल्ट्स. सब में वही आ रहा है. दैट इज योर Ti minus Ti naught is equals to your what is your converted and what is your enthalpy and divided by what is your total in. तो total in की जगह PFR और बैच रिएक्टर में क्या आता है? Your moles at present. Moles at present. In case of CSTR, it is your initial moles only. Zero to XA. Adiabatic maximum temperature rise. Maximum temperature raise or maximum temperature rise for adiabatic case. That is your integration में क्या होगा? XA is equals to limit 1, limit 0 to XA की जगह 0 to 1 हो जाएगा बस. Are you guys done with this?
Yes, sir.
Okay, cool. अभी CP. Okay, CP के what is this CP? By the way, CP mean I am saying whenever I am writing CP mean, it is, I told you what is that? Mean CP. So it is averaged over what? From reference to
Average molar pressure
Temp.
capacity.
what? It is
Average over temperature.
over, right? So it is your temperature reference, final temperature CPI को हम integrate करेंगे and T minus TR, just that value, this only, no more change. And they will say if it is constant, then you can directly take out as CP mean, else it is your integration value. Next part is, this is your first note. Second note is note 2, you write instead of your moles, they are saying CP of mixture and density of mixture is given directly. They have not segregated A, B, C. They are combining collectively and saying density of mixture and CP of mixture is given. So can you guys tell me what we studied in yesterday's class?
Then it will be rho m into CPM.
Okay, so we will be having Ni into individual component, their Cp is equals to your density of mixture into Cp of mixture into what? This is mass, right? So Cp per unit mass, and this is your Cp per unit moles, right? तो तुमने क्या किया, मोल से तो मोल से मल्टीप्लाई कर दिया, यू आर गेटिंग Cp, राइट? ओके, ये Cp क्या है? दिस Cp is your per unit mass. I hope you are getting. This is per unit mass. Per unit mass है, तो तुम्हें क्या करना पड़ेगा, मास से मल्टीप्लाई करना पड़ेगा, मतलब मास. एंड व्हाट इज योर मास? डेंसिटी इनटू
Volume.
राइट. सो यू विल बी हैविंग रो लिख लिया हमने, Cp लिख लिया, इट इज योर वॉल्यूम ऑफ मिक्सचर और वॉल्यूम ऑफ रिएक्शन मिक्सचर, राइट? सो सी इट डिपेंड्स ऑन योर क्वेश्चन. उन्होंने if they have given you individual Cp value, then you need to go for this molar Cp wala, molar Cp concept, molar Cp concept. And जब अगर उन्होंने बोला है कि density of mixture is given, Cp of mixture is given, then you need to go for this term. You can replace that value anytime for liquid phase reaction. This is only temperature effect and here. Please raise your hand if you are done. We'll solve some gate questions. Devang,
Yes.
have you completed this?
Yes, sir.
Okay. So we'll solve some gate questions. Please upload on group gate 2009 2 marks question. A gives B in PFR. If you have, else I'll write gate 2009 question for 2 marks. You can find easy questions were asked from this topic. A gives B. Just one thing you need to have is practice. A gives B is carried out in PFR with Ca0 is equals to 4 kilomole per meter cube. Density of mixture is given 1200 kg per meter cube. And Cp of feed is given, mean directly given. Mean Cp is 2000 joules per kg given. I am repeating here. Please be careful while writing units, okay? 2 marks, both important. Delta H reaction in gate only, okay? In real life, if you know concept, that is okay. Delta H reaction is your minus 120 kilojoule per moles of A. See here it is given. It is per mole of A. Minus 120. Then your temperature max is given 800. Maximum temperature that can be raised in reactor, T max. It is not delta T, right? Then find feed temperature. How can you approach? PFR is given. PFR के लिए density of mixture सब दिया है. And here it is written all things are independent of your temperature.
Well, is it adiabatic or non-adiabatic?
Okay. So if it is not given, then you consider it's adiabatic. If it is not mentioned, then you consider adiabatic. Okay. So I'll try. Temperature should not exceed your 800 Kelvin. So you are having only one equation, that is your Ti minus Ti naught is equals to what? Fa naught minus delta HR reaction integration 0 to Xa, that is equals to 1 in case of maximum temperature, dxa divided by summation of Fi into Cpi was there. So instead of this you can write what? Density of mixture, Cp mean of mixture, and nu naught volumetric flow rate in case of PFR, and it is volume in case of batch reactor, right? Please keep in mind volume in case of batch reactor and volumetric flow rate in case of PFR. अभी मुझे बताओ what is your given data and what you need to calculate. That is your Ti naught. Everything is given, right? Just you need to put the values in proper units. So it is 800 minus your Ti initial that you need to calculate. Fa naught is what? Okay, Fa naught minus delta HR reaction integration 0 to Xa dxa divided by your density of mixture, Cp mean of mixture, and your volumetric flow rate. Can you guys tell me ये density, Cp, nu naught, it is written they are not function of temperature. Not function of temperature, it is given not function of temperature. यहाँ पे will it be a function of conversion?
So like density of mixture can be a function of
Conversion, right? Okay.
Yes, sir.
Yes, it is given. Okay, if it is function of temperature or it is not function of temperature or conversion. Okay, so here in this case I am considering this F density of mixture is not function of your conversion, then it is coming out of your integration. If you have question for this from gate, I don't have exact question there, that's why I'm writing here. Cp is not that much function, but density may be your function of temperature. Density may be your function of temperature. No, density is function of conversion, I'm saying. Conversion Xa. Okay. Suppose if it is not, then please calculate what is your Ti. So we'll get 800 minus your Ti naught is equals to your Fa naught is given as Fa naught minus delta H reaction at temperature T. Okay, it is not function of temperature, right? So delta H reaction is not function of temperature. I told you it is given not function of temperature. Okay, तो क्या होगा डेल्टा एच रिएक्शन स्टैंडर्ड जो रहेगा that is your delta H reaction at any temperature, right? If it is not function of temperature, then it is your XA and it is your divided by density, mixture, Cp of mixture, and your volumetric flow rate. Now please substitute and calculate what is your Ti naught. I'm considering
400.
this if density is not function of temperature here. Density is not function of conversion. Density is not function of your conversion. That's why it is coming out of integration. What is your answer then? Please substitute with proper units.
600, sir.
Okay, 600. Are you getting? I hope you are getting this. Please raise your hand if you are getting. So FA naught is your, what is FA naught? FA naught is CA naught is given to you. So you'll be having FA naught divided by nu naught. You know FA into V is equal to your CA into V is equal to FA. CA into nu is equals to your FA. So FA divided by V is your CA. So you will be having CA naught, and CA naught is given as 2000. Why I am writing 2000? So it is 4000. 4000 because it is 4 kilomole. So we need to convert into moles. Minus delta HR reaction is 120. X is your 1. Density of mixture is given 1200 into this is your 2000. 1200, 2000, and then okay, it is fine. So your Ti naught becomes 600 Kelvin. You can calculate. Are you getting?
Yes, sir.
Yes, sir.
Right. So this was asked for 2 mark, right? The same way you need to keep this in mind. If it is not function of temperature, or if it is not function of conversion, density. If density is not function of your conversion, then you need to take out of integration. Everything is fine. And if it is function of conversion, then it is given that density is equals to your 2x plus 2xa plus xa square, or some kind of equation will be given, right? Here it is not given. कोई equation दिया है क्या density का? No. So we are considering it is not function, and you will be having simple equation. You just substitute the value and get the answer. Now next question, GATE 2002, 2 marks. Ti naught is given 373 Kelvin. Delta HR reaction is given, that is your minus 1 kilojoule per mole at 373 Kelvin. Your Cp of A, Cp of B is equals to 50 joule per mole. It is joule per mole Kelvin, and independent of temperature rise. This reaction is carried out in batch reactor BR. Conversion is given as 50%. You need to find out temperature rise. And reaction is given as A gives B and B is your product. बैच रिएक्टर दिया है, व्हाट इज योर इक्वेशन देन? टेम्परेचर राइज ही निकालना है, सेम इक्वेशन. Ti minus Ti naught is equals to your what is converted, that is your Fa naught रहता है, but it is Na naught here. Na naught minus delta HR reaction integration 0 to xa dxa divided by your summation of Ni into Cpi. Same as your CSTR. CSTR में कैसे remember किया था? Ti minus Ti naught is equals to what is converted divided by what is your total input of energy. So what is converted is Fa naught xa delta HR reaction, what is converted divided by your total inlet, that is your Fi naught into Cpi. ये सेम इक्वेशन क्या हुआ था, चेंज होके Fa naught dxa हुआ था माइनस डेल्टा एच आर रिएक्शन सेम, देन नीचे क्या आया था, इट इज जस्ट रिप्लेस बाय Fa naught is replaced by your Fi, so summation of Fi Cpi mean. बैच में क्या हुआ था, it is your Na naught dxa minus delta HR reaction किससे फॉर्म हुआ, डिवाइड बाय व्हाट इज योर इनलेट, that is your Fi की जगह क्या होगा, it is your Na into Cpi mean, right? तीनों इक्वेशन सिमिलर. Now please try to solve this equation and find out your temperature rise. Final temperature. Ti find out करना है. Ti naught is given is equals to minus delta HR reaction at temperature T, Na naught इंटीग्रेशन में क्या आएगा, 0 to xa dxa divided by your summation of Ni into Cpi mean. Now you guys tell me what is your Ni into Cpi mean. Ni is what? I is what? Plus first tell me what is I.
Na naught into 1 minus xa
Then
into Cpi.
into
I mean
CPI.
CPS.
Okay,
CPA.
you are correct. You are correct. But there is a small mistake, right? यहाँ पे जब हम CSTR के लिए solve करते थे, you are only need you are in a need of what is entering the reactor, right? Fi naught is your what is entering the reactor. Entering. तो entering में क्या consider करते थे? You are just considering what is your reactant because it is pure feed. Reactant only. Why? Considering your pure feed. But यहाँ पे क्या बोला है? It is Fi, right? It is not Fi naught. It is Fi. Means you need to consider what and all component which are coming out of your reaction or which are present inside your reactor, not your inlet. Inlet में क्या हो रहा है? It is not there. It is your all components. So यहाँ पे B आएगा, right? B आएगा तुम्हारा. Please
Yes,
try
sir.
to understand. यहाँ पे
Yes, sir.
Fi दिया है, यहाँ पे Ni दिया है. That's why I'm taking this example. Otherwise तुमने बस A लिया था A component, so you would have calculated wrong answer. So it is your Ni into Cpi, and that is your Na naught 1 minus of xa, right? Into it's your Cp plus your Nb naught plus your Nb naught into Xb into your Cpb, right? So from previous classes, you know Na naught into Xa is equals to Nb naught into Xb because of your reaction content, and then Nb naught is equals to 0. So please write down Na naught 1 minus of XA into CPA plus your Na naught XA into your CPB. तो पता है तुम्हें CPA is equals to CPB. So what is remain then? क्या आ रहा है?
Na naught into CPA, sir.
CPA, right?
Yes.
N naught into CPA. Now please substitute here equation में. So Ti हमें find out करना है. 373 is your inlet temperature is equals to your Na naught into your delta H reaction. It is your 1 kilojoule. So you can write 1000 joules. देखो conversion you need to keep in mind. 0 to XA, right? And XA is equals to your 0.5 is given. dxa divided by your minus this total term. This total term is your Na naught into your 50, that is your CPA. Can you find out this integration? Can you solve this?
Ti is equals to 383.
383, right? Okay.
383.
383. Okay.
Yes, sir.
Any mistake? We'll solve. Ti is equal to 373 plus this is your 1000 divided by it is your 50 only, and this is your 0.5. And here it is plus sign. This is your 20.5 will here. Okay, तो तुम्हारा आंसर आ जाएगा 383, right? I hope you are getting answer. That is in Kelvin, okay? So there are two types of question. If it is asked to find out what is your final temperature, directly it is written final temperature, then you need to tell 383. And if it is there for temperature rise, so what is that? It is your delta T. And यहाँ पे हमें delta T पूछा है. We change here temperature rise and final temperature. So you need to write both. So your final temperature is this and temperature rise is 10 degrees Celsius. Are you clear with this? दोनों चीजें पूछी है. So you can write 383 comma your 10 or it is first written temperature rise, so 10 comma 383. Your answer. Okay. Are you done with this? Should I move?
Yes, sir.
Okay, cool. We'll be having one last topic. It is not topic, it is a part of your MFR only. So for MFR, you know what is your equation. I hope everyone knows what is that equation. Ti minus Ti naught is equals to your, what is your converted, your enthalpy is what, divided by what is your total inlet. Abhi, please remember that is your, this is your inlet only, and it is not considering your products and all, but बाकी इसमें products consider होते हैं. Okay, so you can arrange this in terms of XA. So XA is equal to क्या हो जाएगा?
So it is
Summation.
minus delta HR में.
I am writing Ti minus Ti naught. So Okay, it is minus then. Yeah, Ti minus Ti naught, then it is minus. So you will be having summation of Fi naught Cpi into your delta T divided by your what? Delta Hr in minus sign. This is final temperature minus initial temperature. I'm writing delta T. Delta Hr Fe naught, right? This is your equation. Now, तुम्हें मैंने ग्राफ भी पढ़ाया था. Just it is a revision only. You can see. This is your temperature. This is your XA. This is your inlet temperature. Exothermic reaction है. क्या होगा? Slope is what? This is your slope. X तो पॉजिटिव रहता है. For exothermic reaction, minus delta Hr reaction is positive. क्या होगा?
Slope will be
Temperature
positive.
right? So please tell me what is your so which one is your exothermic and which one is endothermic?
A is exothermic and B is endothermic.
Right? Exothermic and this is your endothermic. क्या हो रहा है exothermic में? तुम्हारा temperature बढ़ रहा है with respect to conversion और with respect to temperature, and यहाँ पे क्या हो रहा है? Decrease हो रहा है. So these are your two curves. Now मुझे बताओ slope की value क्या है? Slope is your this value. Okay. Suppose if you are adding inert, addition of inert. This was your topic, addition of inert. Inert add करोगे तो क्या होगा? यहाँ this is your reaction mixture and this is also your reaction mixture. यहाँ पे pure A है, यहाँ पे A plus inert है. तुम्हें 60 डिग्री तक हीट करना है दोनों को. हीट ज्यादा कहाँ पे लगेगी? Which one will be having more heat required?
A plus inert sir.
Right? यहाँ पे you are having inert भी है और ये भी है. 60 तक दोनों में को हीट करना है. So more heat required, right? So Cp, what is happening here with Cp by addition of inert? Your Cp is your heating capacity, right? Heat capacity. It is your amount of heat required to raise 1 degree Celsius of 1 kg substance or 1 gram substance based on your unit, right? 1 ग्राम का 1 डिग्री सेल्सियस से टेम्परेचर बढ़ाने के लिए what is your heat required? That is your this. So मुझे बताओ अगर तुम्हारा kg बढ़ा देंगे your more heat will be required. So because of addition of inert, what happens? Your Cp overall increases, right? Increases. तो Cp increase होगा तो क्या होगा? तुम्हारा स्लोप क्या होगा?
Increase होगा.
Increase होगा. So right, if it is your slope, then it will increase to higher value. So you will be having this kind of curve. Okay, this kind of curve. Inert. I am writing here inert addition. बढ़ेगा. Then in case of endothermic reaction क्या होगा? Endothermic reaction के लिए तुम्हारा slope क्या है? M is equals to slope. Slope is your same value, but your delta Hr reaction negative है. तो स्लोप तुम्हारा जो था वही रहेगा. Cp से क्या हो रहा है? जस्ट तुम्हारा स्लोप अगर पॉजिटिव था तो बढ़ रहा है, नेगेटिव है तो क्या हो रहा है? नेगेटिव में बढ़ रहा है. That means your shift to this side. Curve will shift to this side. I hope you are clear. This is your slope initial. इसमें भी क्या हो रहा है? एक्सोथर्मिक एंडोथर्मिक रिएक्शन है, स्लोप तो सेम ही है. Cp इसमें भी इंक्रीज हो रहा है. सो योर कर्व का जो स्लोप है इट इज मोर एंड मोर नेगेटिव. मोर नेगेटिव आई मीन्स it is increasing. Slope is increasing, right? When Cp is increased, तो क्या होगा? Your Cp इंक्रीज करेंगे तो तुम्हारा स्लोप इंक्रीज होगा, राइट? So slope increases with increase in Cp value by addition of inerts. तो क्या होगा जा? Suppose if it is this black one, so your slope will increase and it is up now this value, black one. Are you getting? By addition of inerts. Okay. So by addition of your inert, तुम्हारा slope increase ही हो रहा है. So this was about your inert effect. Okay, one question. This will be your homework for today's class. Get 2007 2 marks question. Okay, we'll solve this. We have time. So liquid phase reaction carried out in batch reactor, isothermal case it is written. Okay, it is maintained isothermally or isothermal by removing heat that is generated. So you need to find out what is temperature of coolant that is required in terms of U, delta H, A, V and Ca naught. In this term you need to find out your TCI, coolant temperature. So you know बैच रिएक्टर था, आइसोथर्मल मेंटेन कर रहे बाय रिमूविंग हीट, एंड यहाँ पे तुम्हें सब चीजें दी है, यू दिया है, सी नॉट दिया है, ए एन वॉल्यूमेट्रिक और वॉल्यूम इट इज गिवन. So what is your equation? You must know that is equation. Adiabatic दिया है क्या यहाँ पे? It is written isothermal case. So there are two operations. One is adiabatic operation. Second is your isothermal. It is mentioned your isothermal. Adiabatic is not written and isothermal is written. So you will go for this. Or generally, if it is not mentioned, you can have adiabatic case, as I told you earlier. So यहाँ पे isothermal दिया है. So we'll go for isothermal by removing heat. तो तुम्हारा इक्वेशन क्या था? प्लस माइनस क्यू इज इक्वल्स टू माइनस डेल्टा एच आर रिएक्शन, राइट, माइनस आर ए इंटू वी इज इक्वल्स टू प्लस माइनस क्यू था, बैच रिएक्टर था, summation of d by dt of NiCpi into your volume. Right? यही था इक्वेशन.
Sir, into temperature.
Where?
NiCpi into temperature.
Okay, temperature, right. In case of density Cp, it is volume and it is your temperature. Okay. So what it is saying? Your case is isothermal. Right? This we have not derived, but this is one of the case. First case was your adiabatic, right? Which we derived. But isothermal के लिए we didn't derive any equation, right? तो वहाँ पे क्या होगा? Your temperature is not changing. Here, isothermal case, temperature is not your function of time, right? You are removing heat. So this term will be 0. Are you getting? Please raise your hand. So this is your second case, okay? This is your second case. So you will be having Q is what? U naught, A naught, Tc minus T, right? what and all is unit you are what and all sign you get. यहाँ पे क्या हो रहा है, कूलेंट है तो तुम्हारा TC लेस होगा तो ऑब्वियसली तुम्हारा Q इज नेगेटिव वैल्यू, दैट मींस यू नीड टू रिमूव इट, ऑटोमेटिकली बैलेंस हो रहा है वो. हियर इट व्हाट इज दैट, minus delta HR reaction, what is your minus RA, that is your K into CA, not e power minus KT if it is mentioned, or you can write minus RA as it is. Okay, then what remains, your volume is there. So this is your equation. Now please calculate what is your TC. Okay, options were given A, B, C, D. You need to choose among these four. So your equation will be more or less similar to T minus delta HR reaction K Ca naught e power minus KT. If it is written, you use Arrhenius equation, or you directly substitute minus RA into your V divided by U naught into A naught. This is your separate term. So this is your answer. I hope you are getting this. Right? This was asked for 2 marks. What you guys are thinking now? Temperature effect का topic. How it is? सब मिलजुल के उसी पे आने वाला है. Maximum temperature, right? Either it may be your adiabatic condition, isothermal condition. Just you need to balance. Right?